What is up, students? And today's video we're going to be solving logarithms, expanding them, and condensing them. But as a reminder, please like and subscribe. It really helps the channel a lot. Without further ado, let's begin. Now, before we get into solving a logarithm, we must need to define it first. A logarithm is an inverse of an exponent. It'll help us find what power of an exponent should we raise the base to find our argument. Now let's review the parts of the logarithm. Here we have the log. Oh my god. Alright, so going back to what I was saying, here are the parts of the logarithm. So first we have b, which is our base value, which is the number that we're going to put an exponent on, and x will be our argument, which is like the value that we arrive on after we put the exponent onto the base. Here, a with our last value, which is the exponent. Alright, so let's begin with some easy, simple problems of logarithms. So we have our first one, which is log base 10 and 100 as the argument. So we're looking for our base, right? Our base, and what exponent that makes our base 100. Well, we know 10 to the second power is equal to 100. So the answer is 2. And now let's look at this next one. 10 to the power of what is equal to 1? Well, if we look back into the zero exponent rule, we know that when any number is put to the exponent at 0, it's equal to 1. Hence, our answer will be 0. So we have log base 5 is equal to, log base 5, 25 is equal to what? We're looking for what exponent takes 5 to 25. We know 5 to the second power is 25, so our answer is 2. Now, instead of having our regular numbers, we've implemented some variables. Log base x and then x to the 6. Think to ourselves, what power of x guarantees us x to the power of 6? Well, we know x to the power of 6 is equal to x to the power of 6. So, answer is 6. For this one, I'll have you guys do it by yourself. It's log base ab, and then a to the 7th, and then b to the 7th. Alright, we're back. So, we know that a and b, right? We see a and b, and then we see the exponent 7. So if we raise a and b both to the power of 7th, we get a to the 7th and b to the 7th, which the answer is 7. We have our final one. You notice how our exponent part is always left blank, but this time, it's our argument part. Now, we're going to see now. 5 to the power of 5 is equal to what? So we'll raise 5 to the power of 5. Give me just a moment. And we get 3,125. Now, with the values that we've arrived at, let's try and take these logarithms and put them back into their exponential forms. So we have x, which is our base. Take the x, and then we have our exponent, which is 6. X is equal to x to the 6. Boom. Now we do the same thing with our second one here. Okay, we have a base of ab, and then we have it raised to the 7th power. Boom. Our final one, we have base of 5, and then we have an exponent of 5, and we arrive at 3,125. So before this video ends, let's go over something really quickly. We have log to the 10. We notice that there is no base value. So when log is by itself, right, and there's no base value, the base will always be 10. So think of it as an invisible 10 here. So now we have log base 10 and 10, which is equal to 1. 10 to the 1 is equal to 10. Boom. So as a quick disclaimer, my next video will be on the natural log, which is also part of the logarithms. As always, have a nice day, and please like and subscribe.